Hello and welcome to the University of Pittsburgh's Health and Explainable AI, Pitt HexAI podcast series. Pitt HexAI is a research laboratory at the University of Pittsburgh School of Health and Rehabilitation Sciences Department of Health Information Management. Headed by Ahmad Tafti, the lab cultivates extramural collaborations with other academic institutions, both nationally and internationally, through its research and educational contributions and this podcast series.
Hello and welcome back to Pitt HexAI, a podcast series produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory. I'm Jen Bees, Pitt HexAI's audio engineer. On this podcast, I'm going to guest host special interviews, giving students a chance to get to know different startups working in the cutting edge of health informatics and AI. Today, we're going to speak with Gaurav Kaushik, founder and president of ScienceIO. Welcome, Gaurav. To get us started, would you like to introduce yourself and tell us what is ScienceIO?
We're a technology startup based in New York with folks on the West Coast, East Coast, and the middle of the country as well. And what we do is we create artificial intelligence and tools for developers who are working with unstructured healthcare records to turn those records into actionable data, to understand what's happening with patients, and being able to look at the 2 trillion gigabytes of healthcare data we create each year in the US and turn that into progress for patients everywhere.
What got you interested in health informatics, and what inspired you to start the company? And where do you see ScienceIO positioned in the informatics field?
So before health informatics, I was involved in bioinformatics, where I was doing a lot of gene network analyses, and then eventually I was very involved in cancer bioinformatics, so a lot of next generation sequencing to understand the mutations that cancers can have and how we can essentially learn from them to map patients to the correct therapies. So I was at a company called Foundation Medicine, where I was hired to be the associate director of what we ended up calling real world data. And we had a collaboration with a company called Flatiron Health based here in New York, where we were essentially securely and privately linking our data sets to be able to have patient records where we could see their genomic biomarkers and we could also see their EHR data. And what was really incredible about this is we were learning things about how cancer patients were being treated and how we could better the treatment for patients in almost real time in a real world setting. And that got me really interested in health informatics and in particular clinical informatics, because it was such a challenging process to be able to accurately measure a patient's healthcare status, their history, what sort of treatment options they had from the EHR. Because at the end of the day, EHRs they're billing machines. They're not necessarily patient records. And so one of the things that was exciting about working on that was that we saw the power of having rich longitudinal patient data. But getting that data was still a real huge challenge. So it would take months of curation by oncologists and oncology nurses on our partner side to be able to pull accurate, reliable variables. So you could do things like predict patient progression, patient survival. And we started to think, well, there has to be a way to scale up the automation and give curators powerful tools to be able to do this more quickly than ever before. And I was sitting on my desk, and then the Burke paper came out. And I was sitting there and I was reading it. And I just started to feel more and more that somebody was going to build large language models for healthcare. And I wasn't sure that anyone could do it right. So the hubris of a founder, I said, I want to do this. And so in January 2019, I left Foundation Medicine and we started ScienceIO.
That was really courageous to start ScienceIO. What advice or inspiration can you give prospective founders about jumping in and just launching a startup?
That's a tough question. I think starting a startup, running a startup is the hardest job I've ever had. All the way from being an undergraduate to grad school, which I thought was going to be the hardest, to now it's really been starting a startup, because you're creating something new in the world, and you have to have this dogged belief that the thing you're creating is worth creating and people should want it and people should buy it. And oftentimes, especially in healthcare, you have a clarity of vision that maybe other people don't. And this is particularly true of technology startups in healthcare, where you may see something that the rest of the world just doesn't see. So 4 years ago, I said, I'm leaving to create an NLP startup. A lot of people looked at me and said, why? Like, NLP is just a tool. It's not particularly good. Everything is kind of, hard to use. What you actually want to do is you want to build a patient portal, or you want to do something else. And, you just have to have some convictions that you are solving the right problem. You may be the only one who appreciates that's the problem that needs to be solved. And you have to do the work to just keep yourself going every day, even when it's hard. So what I would say to folks who are thinking of starting a company, particularly in healthcare, is find a problem that is worth solving, and solve it in a way where you can demonstrate value, you can make sure people can use it, you can make sure people want to use it, and that people will eventually want to pay for this, that it is more than just a cool academic exercise. And then just pace yourself, because it will take you probably years. It's not consumer tech. You're not going to have that explosive growth on an app store. You're going to have to run that race for a long time.
For students, and especially ones finishing their PhDs, can you offer any advice on transitioning from academia to the private sector based on your research interests?
When I was making the decision to move from academia to industry, which is the monolithic term that we use in academia for any possible other job you could have, there were kind of two camps of people that I met. And there was the camp that said, you're an academic, so I'm going to stereotype you. You care about one thing. You're going to want to go really deep. You don't have flexibility. You don't know how to solve problems. And then there were the people that were like, no. Because you are an academic, because you have a PhD, you can think critically. You can go in and do the work. You can be at your bench or sit in front of your terminal, and you have determination that other people don't. And so it was very interesting to see people who were biased against me in my experience. And then there were people who were very much no, this is exactly what I need. And I think what's cool about healthcare is that there is a place for people. If you are a master's student, if you're a PhD student, there are plenty of opportunities for you. And the skills that you are building right now are super critical. The ability to understand complex topics like healthcare, to be able to go deep on problems and be able to push where other people maybe don't have the tenacity or the patience to, and the ability to articulate and communicate complex ideas in a way that's accessible and also process those things is so, so valuable. So my advice is, if you are thinking of making that transition, the most impactful thing that you can do is just find people to talk to, ask them as many questions as possible about their career path, and believe in the skills that you are developing as a student. And don't get the idea that your academic work is not preparing you for an industry job, or that it's going to be a hard pivot. It's not. You are growing, and that growth is going to pay off when you leave academia.
Well, there's always been a lot of excitement around technology. Are healthcare practitioners beginning to get excited about artificial intelligence?
We focus a lot on natural language processing, and I think NLP, as it's called, is in such an interesting part of its history, where we've seen unprecedented progress in the last 5 years, thanks to new emerging techniques like the transformer architecture in deep learning. And we're also seeing a greater appreciation on the healthcare side that we can do more with the data that we have in electronic health record systems and data that we collect as part of clinical trials to understand what's happening with patients and turn that into new solutions and interventions and insights. And so it's just a really fun time to start to think about how technology can be used to accelerate a lot of use cases that maybe were being done manually, maybe were being done pretty slowly or in really small scales, but now we can accelerate the progress that we're going to be seeing in medicine. And I would say to most folks listening out there, now is the best time to get into the AI and healthcare spaces, because this is the century for those two topics.
Where's ScienceIO focusing its work data-wise? And what's promising about NLP related to patient data?
So I come from the field of bioinformatics, which tends to be synonymous now with next generation DNA sequencing. What we will focus on right now is more this challenge of there being so much healthcare data and not a really good way to understand what is happening in the data. So I'll give you an example. It's estimated that every year in the United States, we create about 2 trillion gigabytes of new healthcare data. And most of it is unstructured. And by that, I mean, if you go see your physician, if you go see a specialist, they're going to write down how you're feeling and what they think about it and your family history in a note, right? Or in a text box. So when you have all that data aggregated together, it's really hard to search for people who maybe are at high risk, or people who may be eligible for a clinical trial, or people who just need a little bit more TLC, a little bit more outreach from their physicians and providers. And so, we think about healthcare in terms of healthcare informatics as what is the infrastructure that we have built our entire healthcare system on? And from a data perspective, it's very reminiscent of the way you would think about the way offices or financial industries were run in the last 20 years, right? It's very text-based, it's very paper-based. And I think the promise of NLP and healthcare informatics in general now is to accelerate the digitization and the organization of that information. Something you touched on earlier is we have a lot of data, but the advice I give to anybody who's starting out is when you go into a new organization, you're not going to have really clean data. And so big data matters less than having a small amount of very, very good data. And that's also a great place for AI to play a role. How can we take lots of very messy data and get the right clean data so that we can start to understand what's happening with patients?
Would you like to sketch a ScienceIO journey for us? And how are you able to help healthcare providers?
Yeah. So a customer journey we're seeing more and more often now is health technology companies. So thanks in part to the COVID-19 pandemic, we're now seeing more and more people receive their care on online platforms. You might have an application where you reach out to a physician. You might, receive mental health care through that. You might even receive just some basic therapeutics. So all these digital healthcare platforms, right? They're providing you with the ability to access a physician. And the way you do that is purely text-based, just like it is in the electronic health record system. So you're chatting with a doctor, they ask you how you're feeling, what are your symptoms, and then they eventually make a determination. Most of these organizations don't have access to that data, right? You're talking to this physician. So how can they basically say, what does our patient population look like? Which of our patients are being underserved and we want to be able to reach out to them? Or which of them are feeling side effects maybe from the treatment and we want to provide an intervention? So these are just like very basic, pragmatic concerns of an organization that's providing healthcare to their patients. But because of limitations around how the data can be queried or privacy and security, which is super important, they're not able to have that insight. So where we've been able to help there is to, in a secure and patient privacy preserving way, identify what is happening with a patient. What medical conditions have they mentioned? What therapeutics have they mentioned? What side effects have they mentioned? And allow organizations to have that insight into what's happening without it being something that is surveilling the actual patient itself. So that's one of the use cases I think is really interesting is as healthcare becomes more online, we have the opportunity to think about a better way to monitor and care for patients that maybe wasn't possible when the data was locked away in a place where it wasn't accessible even to the patient.
Can we walk through a use case next?
So one of the use cases that we're really passionate about is identifying patients with unmet needs. There's a lot of people in the healthcare system that don't yet have good therapies, good interventions, really solid treatment plans for what they're going through. I'll give you a concrete example. So there's a particularly aggressive type of breast cancer called triple negative breast cancer. And we recently went through this case study where we looked at a healthcare system's records to just try to find the patients who had triple negative breast cancer. And you want to do that because you might want to help those patients get access to clinical trials that have maybe advanced therapies that might be able to help them, or to connect them with specialists that, might be better suited for treating their particular type of cancer. And triple negative breast cancer also tends to affect women of color and women who don't come from means demographically. So it's really important that we are able to, not just serve certain, folks, but serve all patients. Everybody comes in expecting the same quality of care. So we went through this exercise to try to find these patients in the electronic health record system, and we realized it's not easy to do. There isn't a magic keyword that says, oh, let me find these patients who have these unmet needs or who are high risk or who are going to need some special attention. And the way we cracked it is we brought our technology to bear to essentially read through their clinical records and find clues to these patients. Maybe it's a diagnostic test. Maybe it's explicit mention from their physician. Maybe it is a not so explicit mention, but we are able to detect it using artificial intelligence. And now we actually have sightlines to these patients, to this cohort. When we talk to folks who are looking to ask and answer questions about patients with unmet needs, the biggest blocker is finding those patients and organizing their data to even do a simple analysis. So the faster we can find them, the faster we can understand what's going wrong and start to connect them with better solutions or figure out what better solutions there could be for these patients. So that's, I think, one of the most promising opportunities around health informatics is getting us clarity to what the patient population looks like and who needs the most help today.
One thing that's interesting about ScienceIO that caught our attention is your internal knowledge graph. It's pretty crazy. It looks like it's capable of recognizing over 9 million medical concepts. So we'd like to hear more about this. But before we get that far, can you share your thoughts on open data and maybe your recommendations around the need for better data?
I am a big advocate for open data. I think when it comes to healthcare, we have to be mindful of patient privacy and getting informed consent from patients to use the data as part of these initiatives and any sort of analytical project. I also think it's really important for us to start to think about a future where patients receive compensation for contributing their data, which is a conversation I don't think we have enough. It's a hard problem, but if there's a world where we can learn from patients' data and reimburse them for it, that's a win-win, I would say. It would also incentivize folks to share the data that they have for appropriate use. So all that said in mind, I think what we need from a healthcare NLP perspective is better quality data that's de-identified to protect patient privacy, that has been quality controlled by clinical experts, and it needs to be a lot larger than what we have available today. So we've entered this new phase in NLP where we are working on, new deep learning models that are capable of learning from billions and billions of records. And in-house, we have 2 billion labels that we use to train our artificial intelligence. But a lot of the public resources that are out there are maybe a few hundred samples to maybe 10,000 or so. That's simply not enough for folks in the open domain to be able to train an algorithm that is scalable and to benchmark the algorithms that we're creating to account for all the kinds of biases that you might have for an AI algorithm. So better quality, larger data sets, better benchmarks done by a cross-functional group of individuals who are covering considerations from data privacy, data security, data quality, clinical validation. That would be great. And so it'll be, we are thinking very proactively about how we can support the ecosystem from that perspective and partner with other organizations to get more of that data out there into the public space.
Switching topics again, returning to your knowledge graph, on a high level, we'd love to hear more about your knowledge graph, and on a technical level, what was challenging about building it? How does it work? Where do you source your data, and anything else you think students would find interesting?
In order to make healthcare data more useful, right, we wanted to develop an artificial intelligence where any medical condition, any drug, procedure, genetic biomarker, vital sign, you could capture that from unstructured records and then be able to put them into a tabular format so you can do your kind of traditional analyses. And that means that we have to have targets to work off of, right? We have to have a definition. So if we have acetaminophen, Tylenol, paracetamol, those are all essentially the same drug. So we should be able to normalize the data. If we see it in these different forms, it maps to the same thing. And so what's nice is that healthcare has a lot of ontologies that you can work with. You have the Unified Medical Language System like UMLS. Obviously, for billing, you have ICD, you have CPT for procedures, you have RxNorm for therapeutics. There's a lot that you can work with. The challenge we realized is there's too much to work with. And you've probably heard the term garbage in, garbage out when it comes to data. The same is true for how you design the system that is going out and figuring out what healthcare topics are, existent within your data. So here's a thought experiment. And, we actually did this test. Let's say you were to go out there in the industry and you were to pick up a bunch of models that go through your text and they label all the genes and all the mutations in whatever document you provide. And then you say, okay, let's look at all of the possible ways that they could encode a gene. How many encodings are we going to get? How many labels, how many identifiers are we going to get? And so we did this. And for a gene like EGFR, which if you're familiar with cancer is super important, we had 73 different concepts coming out of all these different ontologies. So what that basically said to us was, wow, nobody can agree out in NLP how to call this gene a gene. And then we looked at the Unified Medical Language System. We looked at the UMLS and we said, well, how many EGFR related concepts are there? And there were over 1,000. So now if you multiply that by 20,000 human genes, you have just millions of possible concepts. And that's really problematic because you can't expect an artificial intelligence to deal with that much uncertainty, that ambiguity. So how do you solve garbage in, garbage out? You have to build a recycling plant for your vocabulary. And that's really what it boils down to, is you have to look across the universe of all the different medical ontologies, and to design a smarter system, you have to pick the right ones. And so there's a critical curation step. And that curation step is driven by our subject matter experts. They're driven by PhDs who have worked in bioinformatics or biomedical sciences, who know, in this case, you're going to want to capture this versus that. And that is really awesome because now we're getting to the place where we are increasing the amount of agency that domain experts have in the design of artificial intelligence tools. And so it's almost like we're distilling their experience and their expertise into a more scalable artificial intelligence. So yeah, don't skip over your ontologies. That curation step is super critical. And anyone who is just going to pick up, whatever is off the shelf and throw it at the data, you're going to get really bad results. That's something as an industry I'd also love to see, for us to have much cleaner vocabularies, because that's going to be a limiter in our ability to build better AI systems.
How should ontology curators view their responsibility as curators of data sets, label sets, and tools others use? So how important is getting curation right? And what kind of advice would you give curators?
I love this question. How should curators, ontology curators, data curators view their responsibility? In healthcare in particular, the NLP systems that we are building, they are being tasked to clean up all of this technical debt that we have in electronic health records, in pathology reports, and all of this stuff where it's completely document based. So these NLP systems are going to be helping us find data that's missing from structured fields. And then we're going to use that data to understand patient outcomes. And then we're going to use those understandings to make decisions on new therapies we develop, who gets access to what drugs. So the NLP systems are going to directly impact patients. It's a few degrees of freedom away, but it is driving patient impact. So if you have a curation system that just is very noisy, isn't doing a good job, or is biased in certain ways, that will affect patients. So we take the responsibility very seriously that any NLP system that we have is eventually going to be used in a patient context. And so debiasing and understanding our AI systems all the way from ontologies to data to the algorithm itself is critical.
We hear a lot about large language models like ChatGPT-4, Lambda, and Palm. Can we talk a little about the emerging field of action transformers and the middle ground between humans, datasets, and large language models? How would you define this area of advancement?
That's a really good question as well. Um, I don't know if there's a name for that middle ground, but I do think it's really interesting to see that our use of artificial intelligence tools has evolved to the point where our AI tools are using AI tools to get the job done. So just this week, ChatGPT has plugins now. So it can use Google to answer questions, which means it can pull in context it didn't have before. And for us, we're thinking about ways in which conversational agents like, a ChatGPT could leverage models that are better for a particular task to essentially provide you with that answer. So you could imagine a future where you develop algorithms that are just very good at what they do, right? They do one thing really well. They understand patient outcomes, using EKG data super, super well. And a general agent that's conversational like ChatGPT may not be able to do that, but it may be able to use that AI, that specialized AI, to then provide you with an answer. And we're already starting to see that. And I think that's an interesting evolution of the tools because people, I think, like that better than having to actually write code themselves. Having to orchestrate, a bunch of different AI models and then synthesize the results is not great. But if these broader models can essentially behave as the interface for us to access specialized tools, that's awesome. Then you get a nice balance between user experience and accuracy.
Where do you see challenges from transformers in processing information that's formatted in, say, XML and JSON, for example?
Oh man, the very first piece of software I built at ScienceIO was to convert XML to JSON. We're working with document databases where the XML didn't even have a standard schema, so just figuring out a way to get into JSON so it was easier to use for a myriad of different systems. If I could snap my fingers and make one change in the universe, it probably wouldn't be this, but this would be high on the list. It would be getting rid of XML forever. It's just such a pain. But I do think it's interesting to see that software that I wrote, GPT can write it much faster than I was able to. That's one thing. And two, it could probably just do auto conversion without having to write the code anyway. So this ability to essentially translate between data formats and do the heavy lifting either through code generation or just modifying the data itself, I think will be really useful, particularly as we have to deal with in healthcare a lot of legacy data formats and a lot of conversion. So now, for example, a lot of people are trying to figure out how to get data into FHIR bundles, and then that way you can work with interoperable data exchanges in healthcare. I see a world where you can just provide API docs to GPT or other kinds of transformers, and they essentially do the work of data translation, whether it's from XML to JSON or what have you.
Do you have a favorite data format now? And what do you think your favorite format will be in the future?
Oh, it's so context dependent. My heart, it's still very fond of just your plain old tabular data. Give me a table of data, especially some tidy data, and I will be a very happy camper. And I think that there's a necessity for other kinds of data structures like graph data structures, but there's always trade-offs. So like graph data structures, some kinds of computation on them is really challenging, and they can be very slow, and they can also be very costly. But they do allow you to do certain analyses like neighborhood analyses and centrality much more easily than you could with a table. So again, if I were to go back to like the advice piece, just get as comfortable as you can with as many kinds of data formats. Know your data structures. We don't take data structures classes in many disciplines, but if you can take an elective from the computer science computer science department at your school on data structures, do it. because it's a really useful toolkit to have.
Circling back over to healthcare, would you like to offer any cautionary thoughts around data?
I think medicine is a very complex. It's a very complex topic, and part of the value of receiving your care from trained professionals is there's a lot of blind spots that they're able to identify out of intuition. There's also a personality that you get as part of your healthcare. A lot of physicians I talk to, they still talk about the power of touch in the clinic, right? You can use a thermometer to measure somebody's temperature, but physical contact is able to give you more data than just temperature. And it's also sometimes comforting to have that connection with another individual. So I think there's a balance between using digital services to get access to quality care and being able to actually see a person who is going to have an emotional connection with you and empathize with what you're going through. And, there's probably a hybrid approach that we'll settle into. Sometimes I just have a headache and maybe I need, a quick solution. And sometimes we have a more complex problem. And I think a lot of patients still trust a person over an algorithm. And so what we tend to focus on is how can we take the technology that we now have access to, the algorithms that we're creating, how can we use that to augment the individuals, the care teams who are taking care of patients today, right? How can an algorithm benefit, a cardiologist who is looking at a patient's EKG in the clinic, or a nurse who is tackling a ton of documentation for his or her patient and trying to make sense of, what do they need to do on the hospital floor today? And I think that's where the most immediate interventions are necessary. Let's focus on reducing administrative burden and burnout and helping our care teams be better with technology.
On this podcast, we like to focus on explainable AI. What's your take on explainability and its relevance?
Yeah, it's a great question. So when folks talk about algorithmic explainability, they're usually referring to being able to understand why did an algorithm come up with a certain prediction. And what's interesting is that when we talk to folks in the healthcare sector, they're less interested in understanding why an algorithm made a determination. They're more interested in what that determination would be and how would that determination or that prediction change if the situation changed. And the reason is very pragmatic. Sometimes it's hard to know exactly why your care team comes to a certain conclusion, right? People aren't very explainable. And so, having that expectation of algorithms is something I think the community is still trying to figure out whether that's valid. But even if you can understand why an algorithm is making a certain prediction, you can start to understand the limitations of what that algorithm can do. You can understand how it's biased. What are the situations that it's appropriate to use this algorithm in? How would you mitigate some of the bias that the algorithm might have? And so I think a lot more, especially on the industry side, people are focused on understanding the data that goes into an algorithm and the universe of predictions that come out of it and understanding the limitations, which is great because I think a lot of folks think algorithms can be a silver bullet, but like any tool, you wouldn't use a hammer to screw a nail. And algorithms are exactly the same way. It may be really good in this situation, but it's not good in that situation. Those are the kinds of things that we want to understand.
Where do you see a need for collaborations linking academic institutions, researchers, and startups around health informatics?
Something that I've done in the past, in past roles, is form really strong industry academia collaborations. Especially in the bioinformatics space, where there's a lot of good collaboration on data sharing and also standardizing the way that we learn from data and can turn that into new findings and new solutions. And so I think one opportunity for industry and academia to collaborate on is the creation of better benchmarks for healthcare NLP and healthcare outcomes prediction that translates into things that actually reach patients. to be able to close the loop between findings on the academic side and publications there, and then being able to actually test them in the real world in a reasonable and secure way. And I think that would be really interesting to see, because there's a lot of amazing work happening in academia and in industry, and those kinds of collaborations tend to be exponential accelerants. So would love to see that ecosystem evolve in healthcare informatics even more in the next 5 years.
Do you have any advice for students?
I'm not usually one to give advice to professors, but so, for context, I received my PhD from UC San Diego and did my postdoc over at Harvard. So I have a lot of experience in academia. And I would say that the best thing that you can do if you're a student in academia is to get pragmatic real world experience. I think too often I see folks from academia not fully appreciating the skills that they have and how broadly applicable they can be to so many problems in the real world. I don't know a lot of people who do exactly what they did their dissertation on in their professional life, and I think it would be great to see a clearer communication channel between academia and what's happening in industry. So there's a lot of great professional development programs to help folks in academia learn about opportunities in industry. Simultaneously, there's a lot of great industry academic collaborations for folks to work across those spaces on things that we know are real world problems, but maybe there's no business case behind them, but it's a really good research case. And strengthening that over time would be awesome. I know, me speaking personally as a former graduate student, more and more people are leaving academia because there's just not that many roles that are available. So a stronger emphasis on how to take your skills, your really important skills from your master's or PhD or what have you, and translate those into industry applications would have been tremendous for me.
What are you excited about related to artificial intelligence? And would you like to share any advice on AI for students, as it's changing so rapidly?
So I've been out of academia for about 8 years now. And I think in terms of what ScienceIO is excited about, what I'm excited about is I think that we're just starting to understand how to measure whether an algorithm is good or it's not good, to put it in very simple terms. And if you are a student right now who is thinking about how do I create an algorithm that beats all the public benchmarks and is state of the art or what have you, I'm here to tell you, stop. The obsession in artificial intelligence to boil down the complexities of artificial intelligence to a single number, to an F1 score or some accuracy metric, is inherently flawed. It's the same thing I say about IQ. There's no way you can condense a single individual who has lots of strengths and lots of creativity in some places, and others learns in different ways, to a single IQ metric. It's just not how intelligence works. So what I'm really excited about is for us to redefine how we measure quote unquote intelligence of our algorithms. And so at ScienceIO, one of the ways we're thinking about this is we really care about measuring what an algorithm does, not just in terms of its accuracy or performance, but also ways in which it can veer off of that road. And so it's a term we use internally is called auxiliary metrics. Basically, it's how can we set up tests for our algorithms to see if it has certain kinds of biases. So imagine you have a patient record, right? And it's, Gaurav Kaushik went to go see the doctor and received a diagnosis of non-small cell lung cancer. If I ran that algorithm and I changed the name Gaurav Kaushik to Mia, do you expect the prediction to change? It shouldn't, right? Because it doesn't matter whether it's a man or a woman. You should still detect that, non-small cell lung cancer is part of that person's medical history. And yet we don't do that with a lot of artificial intelligence that's out there in the real world, affecting the way that we consume media online or, other kinds of AI augmented solutions and products that we use every day. And so I think it's really exciting to, I'm starting to ramble a little bit, but this is something I'm passionate about is let's think more creatively about what we're putting out into the world, what algorithms we're putting out there, what are their pros and their cons, and how do they behave, in the same way that we think about the diversity of individuals and how everybody is a little bit different, learns a little differently, and is good at different things. And so I think that'll be really exciting for the AI community to put special emphasis on. And certainly in healthcare, it's really important because you can't run away from these problems in healthcare. It's not social media. It's not online marketing. It's healthcare. It impacts people in very, very direct ways every day. And so it's something that's very near and dear to our hearts here at ScienceIO.
That's very involved. How would you like to see AI impact the healthcare field in the future?
Yeah. I don't know if this is futuristic as much as it's just a reframing of how we use AI in society today. And that is that we have algorithms that are spookily good at knowing what we're like, right? So if you've ever scrolled your For You page on TikTok, or you've ever thought your phone was listening to you because all of a sudden you're getting an ad for Stranger Things 4 and you're like, how did it know that I was just talking about that? It's because these algorithms just know us super, super, super well. I wish that we had that same level of benefit in our healthcare space. If I'm a person, I'll give you an example. My father was diagnosed with Parkinson's a few years ago. Probably that was diagnosable much sooner. And, I've talked to patients who received a breast cancer diagnostic and their doctor didn't catch it. But if they apply an AI to one of their scans from a couple of years ago, the AI catches it, right? But it's not integrated into the system to let them know, hey, you have very early stage breast cancer. So we already have algorithms that know us really well. And the way that they intervene in our lives is to get us to click more ads and consume more media. It would be great to see that ecosystem serving our needs from a healthcare perspective. And I don't know exactly how we do that, but we know the capability is there. The future is here. We just need to focus it in a way that's more beneficial to society.
Thinking about the future and progress being made on the AI front, and particularly related to generative AI, what are your thoughts on ChatGPT? Because I know that it's sort of a mixed bag of feelings for most people. And any predictions on what generative AI will look like in 2024?
Yeah, no, I'm happy to take a moment to think about it. So as we're having this conversation, GPT-4 just came out 10 days ago. And I think a lot of folks are still wrapping their heads around it. I haven't read the Sparks of Artificial General Intelligence paper yet. That's on my reading list. I think what's really remarkable to see is that OpenAI has been able to create a large language model that does zero-shot learning, and that since going from GPT-3 to 3.5 to 4, what's become obvious is that it has gotten much better at hallucinations. It responds to prompts in ways that qualitatively is better. It feels less erratic. And somebody said to me earlier today, like it feels like it's reasoning better, and I think that is really cool. The one thing that I would caution people against is the idea that because GPT-4 is doing a remarkable job of creating human-like language and doing that in almost real time, that it is somehow conscious, or that it is somehow, at a certain level of human intelligence. And there's a really interesting saying that my mind goes back to by the Harvard psychologist Daniel Gilbert, and he wrote that every psychologist at some point in their career writes this sentence: the human being is the only animal that blank. And over the last my entire lifetime, the definition of what goes in that blank has been changing constantly. right? Humans are the only species that uses tools. Okay, but octopuses can use coconut shells as body armor, and chimpanzees put sticks inside anthills and eat ants. Um, Human is the only species that could do art, and now we're starting to see things like Dali too. And I think what people should be cautious about is that what we're learning is that so much of human behavior and what humans are capable of doing can be distilled down into essentially the most advanced mathematical model we've ever had. And now with the scale of the internet and the amount of data that we have, the scale of the compute that we have behind models like GPT-4, more and more of what we thought was only capable of being done by a human is now being able to be done by machines. That doesn't mean that it's more human. It just means that what makes humans exceptional is getting a little smaller. But what is really cool is that humans will become more exceptional over time because now we have access to these incredibly powerful models that will allow us to automate more, do more productive things, use our own innate creativity, which these models do not have, to use them in fun and interesting ways that we hadn't necessarily thought about previously. So it's hard for me to make a prediction on what generative AI will look like in 2024 because I can't predict what humans can do with technology like this. We are just such clever monkeys that I have no clue what people will do. But I know it's going to be incredibly insane, just like how society was completely written by the invention of the internet and the industrial revolution. Democratized and commoditized artificial intelligence, generative AI, is going to completely rewrite the way we think about human intelligence and the way we interact with each other. Yeah, and that's basically all I can say at a high level. Something that I do hope happens is that we enter an era where it's not just one company that kind of holds the most landmark technology. That as excited as I am about OpenAI basically committing to making their tools as publicly available, if not open in their historical sense, is that they kind of put their full spirit into it. Unlike Google, where it was like, oh, we have autocomplete in Gmail. That's great. But if this fundamental technology already existed, why are we waiting to use it? What are we afraid of? So that is nice. Now we have to essentially, hopefully, make sure that these powerful tools are not held in the hands of the few. And yeah, it will be interesting to see if that evolves in the next couple of years, or if there's essentially a monopoly formed around OpenAI. Still thinking about it.
Well, this has been really cool. So before we close, we like to ask all of our guests to offer students who are interested in health informatics a little research project idea. What's something you'd love to see students work on?
That is such a good question. Here's what I'll say. So if you are someone who's listening to this and you're a bioinformatician, you're a health informatics student, what have you, I want to encourage you to get into the scary world of artificial intelligence. I genuinely believe that AI is not something that can only be done by quote unquote ML engineers. The inclusion of your domain expertise, your understanding of the nuances of healthcare data, of healthcare problems, is going to be super critical. It's going to be critical for aligning general purpose algorithms to being more impactful in healthcare. It's going to be critical in implementing AI within healthcare systems. Implementation to make healthcare better is going to be a very long process. And once we've moved on from thinking about, how do we build an AI to do X, and we've started to think about, well, how do we do X even better than we did before? We're going to need you as well. So if you, are hesitant about learning Hugging Face or PyTorch or what have you to start getting involved, please don't get involved ASAP.
And lastly, thinking about contributions students can make, what's something interesting that students have brought to your attention that you might like to share?
Early on at ScienceIO, we had a intern who joined us. She was between her senior year in high school and her freshman year in Harvard, and we gave her a shot to work on early applications with our first artificial intelligence. So we had just created our first LLM. It's 2019, and we basically handed her the keys and said, "Drive and see what you can come up with." And what we learned early on was that accessibility was so important, that making it easy to understand how language models work and how to implement them, how to get people started as quickly as possible on building products with them, and not treated the LLM itself like um, a thing that only engineers can use. That was the key insight that I got from her. And I think anytime that we have people with fresh eyes interfacing with artificial intelligence, we learn about ways in which we can make it more part of the social fabric and less a technology tool.
It's been really great speaking with you today. We've had such an interesting conversation. But before we sign off, what are your plans for 2023 and what exciting things are you presently working on?
Yeah, thank you. Absolutely. So we launched 2 products, Identify and Redact. And these are a different kind of models than we've published previously. These are models that are specifically focused on finding protected health information and either being able to collect it or to remove it from documentation. And the inspiration for this came from seeing a lot of general purpose privacy tools that didn't do a good job on healthcare. So they might remove clinical information, they might remove patient information that's actually super important, right? So earlier we talked about how NLP tools, they can introduce bias, their performance will affect how we learn from patients. So if we're removing clinical information, that's not going to benefit patients. And so we just basically decided that privacy tools needed to care about the domain that they're operating in. And we wanted to build some privacy tools specifically for healthcare. And these are the first iteration of our models. And since then, we've actually published 4 different versions. And with each iteration, we are doing a tremendous amount of work to augment the data that's going into it so that it's getting better at identifying patients, identifying physicians, and we've scaled up the training data really, really quickly. So we're super excited on where that's going. And then the other big initiative for 2023 is our central philosophy when we started the company was that AI is more powerful when it's in the hands of people. And these are not going to be technology systems that are kind of sitting in a silo and we can expect the AI to do 100% of everything. That expertise and experience matters. And we really want to focus on how we can give people agency in how AI tools can be used and how they can learn. So we are launching an annotation platform later this year where we'll be able to take expert feedback into account to help the models learn over time. So if you imagine being able to provide not just artificial intelligence to a physician who's trying to summarize all of the clinical notes in the EHR, but then to give them the ability to actually give feedback to say, this is correct, this is not correct, and then be able to privately and securely have the algorithm learn from their experience is going to be invaluable. And this is essentially how we can make sure that these systems are constantly being aligned to the values that we have to create transparent, fair, equitable healthcare, and also to meet with the expectations of accuracy that practitioners have. So the ability to customize and fine tune and put the power in the hands of the people is where our product roadmap is heading through the end of the year.
What would you say to students and others interested in, let's say, experimenting with AI and tools like yours who might feel a little intimidated or too inexperienced to really know how to get started?
When we started 4 years ago, the learning curve was massive. There wasn't a lot of infrastructure built up, but there has never been a better time to get involved in artificial intelligence. You have really powerful libraries like the Transformers library, where you can benefit from the community's pre-trained models. There's interfaces online where you can play with the models to get an understanding of which ones more closely meet your need. Computation is a little bit easier because you have notebook tools like Google Colab and other notebook-based solutions where you don't have to worry about provisioning, a GPU, and then, being able to figure out how to run the code. So there's a lot of tools that have now made it easier to start to learn artificial intelligence. There's even a lot of data sets that are out there. So what I would say is the way I started, the way I, decided to go into a career in data science and AI after my academic career was I just thought of a project that I thought would be cool, and I decided to build it. One of the first things I built was a software tool that would recommend bike routes for me as I was biking around Boston, and I got bored of my usual commute. And so that forced me to learn how to use databases properly and how to use different APIs that I had never used before. So think of something you'd want to do that's pretty cool. Maybe you want to build a nice summarization bot. Maybe you find literature is really hard to mine, and you want to be able to find papers more accurately or summarize papers more easily. Start from that kind of a problem. Look at what's out there for solving tasks that are similar to the one you're looking for, and then just play around with it. Fork a repo and just get going.
Thanks again, Gaurav Kaushik from ScienceIO. See you guys later.
Thanks everyone for tuning in and for following the show. And a special thanks to the University of Pittsburgh School of Health and Rehabilitation Sciences, Department of Health Information Management, and to Pitt's Health and Explainable AI Research Laboratory for launching this podcast. We'll see you next month.